Let's go through LeetCode 2949. Count beautiful substrings 2. For this question, to give us a string s and a positive integer k. In the letter voice and consonant to be the numbers of voice and consonants in a string. So it defines a string is beautiful if the voice counts and consonants counts are equal, and also the voice and consonants the counts mod by k equals to 0. So that means, for example, we have L voice, right? So that means L square should be some kind of number multiplied by k, right? So for this kind of how can we handle this kind of scenario, right? So the first condition was equals constant. That what we're thinking about is that for every character, if it is voice, we use a 1 to represent, and if it is voice, we use 1, and it is constant, we use a -1, right? So we are trying to, for the first condition, it is pretty simple. That is, we are trying to find how many subarrays they have the subarray sum equal to 0, right? So we can use the prefix sum, right? Or we can calculate prefix sum in advance, or use a hash map, right? Hash map key will be the sums of these kind of substrings, right? So the sum, the characters has been converted to be 1 or -1. The key will be the sum, right? And then the value will be the pair times, right? So at the beginning, we can put 0 and a pair ones to this prefix sum map. So how many substrings they have sum equals to 0? There are a lot of similar questions, right? So this is the first condition. The second condition is the voice multiplied by constants and should be some kind of number multiplied by k, right? So how can we handle the second question? The second question is that we know for every k, right, it can be write as a number, for example, a square multiplied by b, right? So for example, a starts from 1, right? So if we have L square, they can mod by k, right? So what is the smallest L we can have? So we'll say we trying to find this a, right? So we'll say so L should be able to multiply a multiplied by b, right? So that means if we have L squared mod k equals to 0, that means we should have L mod by a multiplied by b equals to 0, right? So we're trying to find the largest a here, right? So if we find this largest a, that means for any voice number that kind of L, right? They should be able to divide by a multiplied by b. So we know for the substring, it is 2L, right? So that means for this kind of length, right, any substrings, they should be able to multiply by 2 multiplied by a multiplied by b, right? So how we have another condition is that we can count how many substrings there are, and those kind of times of 2 multiplied by A multiplied by B, right? So we use this, for example, this as a D. Okay. So how many substrings they are the some kind of times of D, right? So so this is also there is another question similar to this. That is, we also use the prefix sum, right? That we want the those kind of lengths, right, to be multiplied by divided by D. That means we use the map key will be, for example, our index I divided by D, right? So if in the future we have another J, right, divided by D, we see the map has how many counts of this kind of J divided by D, right? That means we will have those kind of many subarrays can be those kind of lengths will be divided by D. So that means we can use another map to handle this, right? So that is another prefix map. So of course we can also use the pre-processing to write those kind of reminder to create a reminder subarray first, right? So we can consider using one map, right? One map. The key will have two values. One will be those kind of sum of voice or constants. Sum is 1 or -1, right? And another value will be those kind of index modeled by D, right? So that means if we, for example, we go to an index and we look up this map. If we find, for example, those kind of sum value appears in some kind of previous calculations. Also, this kind of index calculate in the previous calculation, right? Then we can get this kind of counts, right? So we need to have both the sum and reminder equals, and then that means at this kind of index we can have we can add it to our result. So we need to have pair to handle this kind of keys, right? And we can also, to handle this, if we don't want to use pair, we can have this kind of reminder, for example, left to shift to 16 digits and or the sum to create another integer for the key. But the thing is that we need to store two values as key, right? So let's begin to write code for this. We are first write an toInt function, right? toInt with the char C. So what we do is that return C equals this if this is a var or a e I o u, right? We set this one as 1, otherwise set this one as -1, right? Let's change this one to be array as to array. So we want to find the minimal d here, right? So let's set in the d equals to 1, right? So what we need is for int I equals to 1, right? I multiplied by I small equal to k, I plus plus. Because this k is just a 3,000, so we can calculate this d first, right? D, what is d, right? D is, we know k can be right as a multiplied by b, a square multiplied by b, right? So we need to have 2b. That is the L, the length, the count of voids should be divisible by ab, right? So d will be 2 times this value. And so what we're going to do is that if we k multiplied by I multiplied by I, then we'll have d equals to I, okay? And we need to have d equals k divided by d, right? And also we should have 2 times this, right? 2 times. Let's get the result. Long result equals to 0L. Yeah. We have an int sum. Let's have a map, right? Integer. So we know this integer will have 2 parts. One part will be the sum of the voids or contents. Another one is the index modeled by d, right? So the key should have 2 values, and the 2 parts, and the value should be the counts, right? So we call prefix sum equals new hash map. So we'll say prefix sum. We should put 0 and count is 1, right? The sense that if we use one integer to represent the key, right? The key should have the 2 parts. Should be the sum, right? So this will voice plus constants, right? And the left shift 6. Let's have possibly put the reminder, right? Index, remember by b, left shift 16. And the second part is the sum, right? This will be the key. The thing that this sum, it can be negative, right? So if we do like this, we can have a sum add up to n, right? So let's do into sum equals n, right? So that if we use a -1, it will always be positive. So let's have sum here, right? And then the value will be its counts. So what we do now is for int I equals to 0, I smaller than and I plus plus, right? And we have sum plus equal to 2 int array I. So what we will see the key, right? Key will be this kind of I multiplied by D. Actually, this will be I plus 1 multiplied by D, right? I plus 1, because its length will be one more index. one more than one more value than the index, right? So this one, left shift 16. And then the second part will be our sum, right? This will be our key, right? And let's try to consult, look up the map, the count, right? Count equals prefix sum, get key, right? So our result will plus equal to count. And now we'll update our prefix sum map, right? So we'll have map put key count +1, right? And in the end, we just return result. We should have this. This one should have brackets. I key equals multiply D O left shift to 16. Oh, there is an actual. Yeah, right. If this one equals to 0, right? Okay. We don't have n, right? Let's have a n equals array dot length. 21 should be prefix, not a map. Because it may not have this key, let's set a get or default, right? Get or default key 0. So doing like this, the time complexity will be, because this is have square root of k, right? So so for this one, it will be O, the prefix sum, that is ON, right? So so the time complexity will be ON plus square root of OK, right? K is a smaller number, right? So let's say it's ON's time complexity, and space is linear, right? Only ON.